Hello everyone. Today we are going to be working on Lesson 51, Simplifying Fractions. This should be a review for a lot of you. You've been doing this anyway. You just didn't know it may have been called Simplifying Fractions. So first thing that we're going to learn is how can I simplify a fraction? What does it mean? Well, you can simplify a fraction by reducing the fraction to its lowest terms. You can also simplify a fraction by converting improper fractions to mixed numbers. And sometimes you need to reduce a fraction and convert it to a mixed number all in the same problem. Now, this is really important, so I encourage you to write this down. A fraction is in its lowest terms if the only common factor of the numerator and denominator is 1. So what do I mean by that? Let's take the fraction 2/3. What is the only common factor? What is the only number that goes into both 2 and 3? You should be thinking 1. What about 4/6? Is 1 the only number that goes into both the numerator and the denominator? No, we know that 2 goes into it, so we know that this fraction right here can be simplified. What can it be simplified to? It can be simplified to 2/3. Okay? Your other option for the converting improper fractions is if you have a fraction that looks like 9/6. Okay? So 9/6 can be simplified to 1 3/6, which can then be simplified to 1 1/2. And let's go ahead and take a look at example number 1. Okay, so example number 1 reads, simplify 4/6 plus 5/6. Okay, easy enough, so let's copy the problem down on our paper. 4/6 plus 5/6. Okay, we're in good business because the denominators are the same, so I don't need to find a common denominator. I can just go ahead and add the numerators to both sides. So 4 plus 5 is 9, and then we know that the denominator stays the same. So we have 9/6. So now it says simplify. So simplify means do not leave this answer looking like this, okay? So we have two choices. This is one of those problems where we're going to have to reduce and convert, okay? So I'm going to show you two different ways that you can do it, and the first way is by reducing first. So if we reduce it first, then we will, let's copy the problem, our answer over. So 9/6 is equal to, what number goes in to both 9 and 6? You should be thinking 3. 3 goes into 9 3 times, and 3 goes into 6 2 times. And then I'm going to convert. 3/2 reduces to 1 1/2. So that's the first way you can do it. The other way you can do it is by converting first. So let me show you how that would look. Okay, so let's copy our problem again. 9/6 is equal to, if we convert it first, that means we're going to put it in a mixed number. And we learned that 9/6 is equal to 1 3/6. Okay, but look at this 3/6, guys. 3/6 can be reduced to what? You should be thinking 1/2. So that then reduces down to 1/2. So essentially, we did the same exact thing. We just did it in a different order. On this first example, we reduced it and then we converted it to a mixed number. In the second one, we converted it to a mixed number and then reduced it. Doesn't matter which way you do it. Okay, let's take a look at example number 2. Let's read this together. Stephanie sewed a costume following a pattern. The pattern showed 6/8 inch seam, but Stephanie needed to increase the seam by 4/8 of an inch. What was the size of the new seam? When you simplify the answer, decide in which order you will reduce the fraction and convert to a mixed number. Okay, so this sounds easy enough. Let's underline the most important information. So the pattern showed a 6/8 of an inch seam, but then she realized she needed to increase, keyword increase, by 4/8 of an inch. then let's underline what our question is. What was the size of the new seam? So we need to figure out whether we need to add, subtract, multiply, or divide. There is one key word in here which is telling you, hey, you need to do this operation. What do you think that is? If you're thinking increase is the key word, you are right. We need to increase, which means we're going to need to add. So our addition problem is going to look like this. 6/8 of an inch plus 4/8 of an inch is equal to 10/8 inches. Now, our question is saying, what was the size of the new seam? And then simplify the answer. So this is our answer, but we need to simplify it. So we need to decide whether or not we want to reduce or convert first. I think I would like to reduce first. So that's the method I'm going to show you. So we're going to reduce first. So we have 10/8. Let's think what number goes into both 10 and 8. 2. So 2 goes into 10 5 times. 2 goes into 8 4 times. Okay, so now I have 5/4 that cannot be reduced anymore, but it can be converted into an improper fraction. So now step 2, I'm going to convert. So 5/4 is equal to 1 1/4 inches. And we just solved and simplified this example. Now, could you have done this the other way and turned 10/8 into a mixed number first and then reduce that? Sure, you could have. That would have looked like 10/8 reduces down to 1 2/8. Okay? And 2/8 reduces down to 1/4. So our answers still would have matched because we got 1 1/4 inch over here and 1 1/4 inch over here. Let's take a look at example number 3, our last example. Jarrell ran in a race in which he would complete 25 quarter-mile laps. After running several laps, his coach told him he had 3/4 of a mile remaining. What distance has he already run? So let's underline some of the most important information. So we know that total, Jarrell is going to run 25 quarter-mile laps. After running several laps, his coach told him he had 3/4 of a mile remaining. So our question is saying how much is the distance that he has already run. Okay, so this is a subtraction problem. So we know that Jarrell has to run 25 quarter-mile laps. Okay, total. We can write 25 quarter-mile laps as 25/4 because what we're saying is 25 of 1/4. So this is 1/4. And Jarrell is running 25 quarters. Okay, so that's why I can write 25/4 because I'm basically saying 25 1/4 laps. Okay, so after running several laps, his coach told him he had 3/4 of a mile remaining. So to figure out how much Jarrell has already run, we can subtract 25/4 minus 3/4, and that will tell us how much Jarrell has already run. So 25 minus 3 is 22/4. Now keep in mind this entire lesson is about simplifying, so we need to look at 22/4 and ask ourselves, what else can we do? Can I reduce? Can I convert it to a mixed number? And the answer is yes to both. So because in example 2 I started with reducing, this time we'll start with converting to a mixed number first. So first we're going to convert. And to do that, we'll write 22/4. You always want to copy your answer or what you're working with, miles. And let's ask ourselves what number goes in to 20, how many times does 4 go into 22? And it goes in 5 times with, let's see, 2 left over. And if you need to work out this math, you absolutely can. And then we need to reduce. And 5 2/4 reduces to 5.5 miles. And that's it. So we now see that Jarrell has run 5.5 miles already, and he has 3/4 of a mile remaining. And that's it, ladies and gentlemen. Simplifying is that easy. You need to ask yourself, can I convert? Can I reduce? If you cannot do either of those, then your answer is in its most simplified form. Great job, everyone.